welcome to the AP ECE Chemistry Chapter 9 Liquids and Solids Review problem set. Let's take a look at problem number 3. In problem number 3, you're told that you're working with a substance C10H8 that has a vapor pressure of 0.300 millimeters of mercury at 25 degrees Celsius. The first question in part A is how many milligrams of this substance will sublime into an empty 1 liter flask? So you use the ideal gas law, PV equals nRT, and rearrange to solve for mass, and with a substitution in there as well for mass over molar mass. When you solve for mass, you get a value of 0.00207 grams of C10H8 that can sublime into a empty 1 liter flask, or 2.07 milligrams of this substance. For part B, you're dealing with a specific sample now, a 0.7 milligram sample of this substance C10H8, and it's being used. And you want to know what the pressure will be and what states of matter will be present. Since you just figured out what the vapor pressure would be from above, you compare 0.7 to 2.07, and you see that since 0.7 is less than 2.07, all of it should vaporize. If all of it vaporizes, you can figure out what the pressure will be using the ideal gas law, and you plug in for pressure of the ideal gas law. Volumes on the bottom, we've got our R, we've got temperature, must use Kelvin, and then here you've got your number of moles, which is mass over molar mass. And you find out that you get a pressure of 0.000134 atmospheres, which is the same as 0.102 millimeters of mercury. And then since that is all going to vaporize, since 0.7 milligrams is less than 2.07 milligrams, you only have vapor present. In part C, you're still working with the same substance. They're saying if 4 milligrams of this substance is used, what will the pressure be? What states will be present? Now 4 is greater than 2.07, so you're only going to be able to get to your maximum vapor pressure, and then there's going to be some solid left. So the maximum vapor pressure was established before, when the 2.07 millimeters will sublime. So you know what is going to be left. It's going to be the subtraction of 4 minus that, and you know the pressure is going to be 0.3 millimeters of mercury. It's going to be solid and vapor present in this one. Let's take a look at problem 7. In problem 7, you're dealing with a substance that has a vapor pressure of 197 millimeters of mercury at 23 degrees Celsius and 498 millimeters of mercury at 45 degrees Celsius. They want to know what the enthalpy of vaporization is, so the amount of energy required to vaporize this substance. And you use the Clausius-Clapeyron equation, and it's kind of a plug and chug and then rearrange, but make sure you use Kelvin here, and make sure you use the correct R value that's got the joules in it. Your pressure values don't actually need to have any specific unit. As long as it's the same unit, they'll cancel out. And they want to know what the normal boiling point is for this substance. And so you use the same sort of equation, same Clausius-Clapeyron equation. Now that you've solved out for delta H vap, you can plug that in, and you pick either one of the two sets of values from part A and plug them in. I went with the 197 and the associated 296.15 Kelvin. And then I plugged in for normal boiling point. I made normal air pressure 760 millimeters of mercury, and then solved out for T2, which I found as 334 Kelvin. Take a look at problem 17. In problem 17, you're considering a phase diagram for CCl4, which I did not picture here. Apologies for that. But you're looking to see what things are true about it, and they give a bunch of different examples here. They say which point will show solid vapor equilibrium, and that's point A on the phase diagram. They want to know what is point G called. That's where you got a supercritical fluid. They want to know does the boiling point increase as the pressure above the liquid increases? The answer is no to that. They would like to know at which point is it only a gas. That's point F on the diagram in the book. They would like to know does the melting point increase as the pressure above the solid increases? The answer is yes for this. And then can sublimation occur at any temperature? The answer is no. And for a temperature above point E, will the pressure of the liquid be greater, the density of the liquid be greater than the density of the solid? And the answer is no, as with most substances that have the same sort of slope, the positive slope of the line that separates the solid from the liquid.